Okay, let's proceed with our 10th example. Now, what is shown here is not a double integral, but rather a triple integral. Now, for the if the double integral, the lower and the upper limits, or the inside and the outside boundaries, form a region in which we were able to get an area. In the triple integral, if you can see, we have the x, y, and z coordinates. It means that the triple integral is the volume of the region. So what will happen with the triple integral? Same concept with the double integral. You integrate first the inside, followed by the second one, and followed by the third one. Same concept applies, just that it's a bit or quite longer. So we have here, first one we have the with that is with respect to z. Therefore, the x and the y is considered as a constant. So matik na, that is just equal to, if we integrate that, we will have the e to the x times yz plus z squared related from 0 to x plus y dy dx. And then you just substitute the lower the upper limits sa with respect to z. So we have 0 to 2, 0 to x, e to the x times yz. So you have the y times dz, x plus y plus x plus y squared. And then 0, that is just minus 0, dy dx. Simplify that, we have 0 to 2, 0 to x, e to the x. And so if you distribute this, we have the xy plus y squared plus x squared plus 2xy plus y squared dy dx. So ako lang siya distribute for ease in integrating. We have 0 to 2, 0 to x, e to the x. Then we have x squared plus 3xy plus 2y squared dy dx. Now, looking at that one, that is to be integrated with respect to y. So all x, all that is not a variable for y will be treated as a constant. So we have 0 to 2 e to the x times x squared y plus 3 halves xy squared plus 2/3 y cubed evaluated from 0 to x. Let's continue that. We have the 0 to 2. We have the e to the x. We have the x squared y plus 3 halves xy squared plus 2y squared dx evaluated from 0 to x. We have the 0 to x, e to the x times y. If we let y is equal to x, then we will have our x cubed here plus 3 halves x cubed plus 2. Oh, we forgot this is 2/3. This becomes 2/3 y cubed. So we have the 2/3 also x cubed dx. Since puro mo na sila x cubed, then we can obtain a 19 over 6 x cubed dx. Because na to si constant, we have the 19 over 6 integral of e to the x cubed dx from 0 to 2. Now we integrate this using integration by parts. Okay. if we let our u is equal to x cubed and our du is equal, then our du will become 3x squared dx. If our dv is the e to the x dx, then cv is equal to e to the x. So we use this u and v for the is in solution. So ato lang sa ning ipagawa si 19 over 6 sa kanilang sa ang ato evaluate. Ato lang sa ning i-disregard sa si lower and the upper limits. So we have the uv, so we have the x cubed e to the x minus integral of v, that is e to the x, and then du is 3x squared dx. So we have an integral here, another integral. Okay, let's isolate po nato ni siya. So we have, so si 3, ato lang na ipagawa si 3. Buta lang nato diri si 3. So that is, we also have again the e to the x and x squared. So for this one, let's say our w is equal to x squared. Therefore, our dw is equal to 2x dx. And our dv is equal to e to the x dx. And v is equal to e to the x. So we have uv, that is x squared e to the x. Ah, so this should be z and dz minus integral of z dw. So that is e to the x times 2x dx. Now this time again, na napunta integrate na sa natin siya. So si 2 ako lang ipagawas, that is a constant. Okay, let's rewrite again. This is for this term, ha. So for that term, if we let our m is equal to x, therefore dm is dx. And if we let our n is the e to the x dx, then our n is equal to e to the x. So that is just equal to mn, that is x e to the x, minus integral of n dm, that is e to the x dx. And finally, we have x e to the x minus e to the x. Now, hinahinay na to substitute since this one is equal to this one. So we have that is equal to negative 2 times x e to the x minus e to the x. So medyo taas na siya kung ano, solution. And then, this one is equal to that one. Okay, ato lang isulat sa ibabaw. We have the x cubed e to the x minus 3 times we have the x squared minus e to the x, x squared e to the x rather, minus 2 times x e to the x minus e to the x. Okay, we have the x cubed e to the x minus 3x squared e to the x plus 6 times x e to the x minus e to the x. Further, we have the x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x. And we just simplify this. Ipagawas na to si e to the x. Then we will get e to the x times we have the x cubed minus 3x squared plus 6x minus 6. And then we evaluate that from what is our lower and upper limit from 0 to 2. And from that one, we will get that our final answer is just equal to approximately 65.797. So if you notice no, ang katong mga lisod yung kinatong part is from our first discussion. Now we just try to apply those basic concepts of integration in solving these different differential equations and then in applying them when getting the volume and then the area of the object. Now for this one, this is again, this is the volume. So this is in cubic units. So again, no, first is we solve the inner, the middle, and then the outer. So yan na lang siya concept and then eventually you'll get to your